Hello, here we are for Project Euler number 5. I know it's been a while, so let's just get into it. So it says here 2520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. I would agree. And then the question is, what is the smallest positive number that is evenly divisible by all of the numbers from 1 to 20? So I think I can probably go ahead and rephrase this problem into, instead of asking it in that sort of slightly complicated way, I think what it's really asking is what is the least common multiple, can't spell, common multiple of numbers from 1 to n. Um, so I think the way to approach this is to figure out how to find the just the least common multiple of a pair of numbers, and then we can apply that function to the entire list. So let's just write down a sort of placeholder, I guess, for least common multiple, and that's going to take a pair of ints, and it's going to spit out another int, and they're not both going to be called x. One of them will be called y, and then we're going to see if we can write some sort of skeleton code, see how this would be used to turn a list of numbers into the least common multiple of that entire list. So I guess we can get a sort of list of numbers using our lovely iterator.range from 1 to n. Let's just say n is 10 for now. And then all we're going to want to do really is just reduce over least common multiple. Like that. And if I assign this a value, hopefully it will be in int. I hope I've got that right. Yes, it is great. So now we probably want to think about how to implement least common multiple. So to do that, what we're going to do is we're going to multiply x and y, but we're also going to divide by the greatest common divisor, or GCD, of x and y. And the reason for that is because we don't want to double count the greatest common divisor, because if we didn't do this division, we'd end up with a common multiple. It just wouldn't be the least common multiple. So doing this division will get us around that. So now we just want to make sure that we can implement a GCD function, which can take again an x and a y like this. So there's a couple of ways to do this. You can use something called Euclid's algorithm if you want to, or if you're incredibly lazy like I am, you can just remember that Scala actually has this kind of built into it, like this. So that'll give us the greatest common divisor, and then let's just turn it back into an int, because we're just working with ints here, right? Like that. And I can't spell. Tie int is not to int. There we go. And now I guess we just want to see if this works. So you've got to remember we want to actually include 10, and then if I just delete this, my sort of timer thing prints out stuff anyway. So if I just go ahead and run this and see what happens, hopefully that'll work. Well, it seems to have worked. It's taken an absurdly long time for such a simple calculation, but maybe my computer's got sorts of things running on it. Let's try it with 20 then, as for the first 20, which is what the question is actually asking. Well, it's about an answer, but that's obviously not correct because I'd expect an even number. I suspect some sort of integer overflows at play here, so let's have a look. So I'm just gonna really naively just log out some stuff, and let's see what's actually going on. So if I call out the result, and then I just do print line of res, and then I return the res. Let's see if it gives us any sort of negative numbers or anything weird like. Right, so you can see here it's it goes up and up and up as you kind of expect it to, and then it goes back down to this. So I think you've got to remember that the biggest integer that's allowed is about 2 billion. So it's probably just gone over that, hasn't it? So I reckon the solution is just to use big ints everywhere. So why don't we try that? Let's try that. So by. So sort of Oprah style, you get a big in, and 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 you are not an int. Alright, and then obviously these guys need to be big ints as well, so let's just map them to big ints like this. And let's see what happens. And it's probably a good idea to like. I mean, to be fair, like now that these are big ints, I can just do like x GCD y. There we go. All right, let's run this and I guess just see what happens. Interesting. I don't think the answer's 20. I suspect it's just like taking that group, which would be like, yeah, y GCD'd with itself, which will always be, it's, yeah, yeah. So we just need to put brackets in the right place and, you know, hopefully it'll work. That's the joy of using these like symbols and not the sort of, I guess, little dot notation. All right. Yeah, this looks like a much more believable answer, and I think this kind of explains what was going on before. So you can see that this is like, it's about two. Yeah, it's about 200 million, and then the final step of and this is clearly divisible by 20, right? So the final step of the original algorithm I wrote would have tried to multiply this by 20 as the first step, and once it's done that, that's going to go over 2 billion, which is about what the integer overflow is. So it's that's why it fails the first time. So that kind of explains it. And I think like I could have got away with using longs instead of big ints, but I guess big int has the GCD thing built in, which is nice. And this also kind of shows me that like this kind of algorithm that I've written up here isn't really ideal because like it seems to pre-multiply stuff too much, whereas I think there's probably an algorithm you could implement that would work with ints. I'm just not smart enough. So I've just gone with a quick and dirty thing, and it's kind of works. Mind you, we've not actually checked. We've not actually put this in, so this might still be wrong. So let's go and ask Project Euler. Yeah, like I wrote it in before, but then I realised like obviously it's not correct. 1T111. Yay! Alright, well, that's how you do this one. Just watch out for integer overflows, I guess, is the kind of message of this video.